Hi there, welcome back. Now we're going to discuss chapter number 4 regarding lateral logs. Here, this first image shows you how a lateral log looks. This tool is basically a bunch of electrodes within a sound. Those electrodes are isolated by fiberglass in most tools. So, lateral logs as induction tools will provide you with values for resistivity. The objective of running whether an induction tool or a lateral log is to get the formation's true resistivity values. So, in this case, the principle of this tool is that we inject a current into the formation through one of these electrodes. In this case, we're using electrode A sub 0. It is like a complicated name for that, but that is basically an electrode injecting current into the formation. So that current ideally will travel through the formation and will go back to another electrode. This will be the signal that we will use to get the formation properties. But as you can see, there are other bunch of electrodes. Let's see why. So if we try to inject current through one electrode only, the natural behavior will be that current will flow through the path of least resistance. So it will flow through the borehole and will never touch the formation. Therefore, we won't have any values for formation through resistivity. So what we do in order to overcome with this situation? Well, we emit, or the tool will emit another different current. In this graph, you'll see that the black lines are the measured current, the one that we are interested in, and the other one called bucking current. Those currents, the only purpose they have is to guide or to force the measured current to go into the formation. So that is a good schematic. So we're not emitting just one current, we're emitting, in this case, two. Regarding the logging conditions, remember that for deciding if we're running a lateral log or an induction tool, we must take into account the ratio of the resistivity of the mud filtrate and the resistivity of water in the formation. Now we will cover the physics of the measurement. In short, this is the Ohm laws. According to that, you can state that the resistivity equals the voltage divided by the current. In this case, we add a geometric factor, we call it K. That is basically dependent on the area in which the current will go. Here you can see that there is a couple of electrodes that monitor electrodes are called. The purpose of this is just to sense that everything is behaving properly, to check that we're emitting the survey current, and to check that the bucket currents are doing their job. On this image, you can appreciate the area. This will be like the volume that your tool is able to see. Keep in mind that lateral log will give you resistivity for your dip and for your shallow measurements. So the current return for a shallow resistivity curve will be closer to the point where you're emitting the current. So this will be the behavior. For your deep, the current return should be farther from the electrode that is emitting the current. So this will be the behavior. In short, this is how it looks. you're emitting your deep survey current, which is kept in place by these two focus current, and for your shallow measurements, the current will go out from the same electrode but will return to a different one. So that's pretty much all. Thanks for watching.